Let's come to the merits and demerits of the meaning. So basically, arithmetic mean is the most commonly employed measure of central tendency. So in particular, there are some commonly and some following merits are there. So first one is basically mean is very simple to understand and is easy to calculate. So the calculation of the basically the arithmetic mean necessarily a basic knowledge of addition, basic knowledge of addition, multiplication, and division of the number. As in mean, we add all the items and divided them by the total number. So therefore, even a layman with elementary knowledge or with a limited knowledge can calculate the arithmetic mean. So with the help of arithmetic mean, it is very easy to figure out a particular item or the particular cost of unit. Next merit of mean is certainty. So as in arithmetic mean, we use algebraic formulas to define the arithmetic mean. So everyone who calculate the average, he will get the same answer with ultimately using all the elements, all the chances for the personal biasness. Okay, so how these values of mean are very certain based on all items. As when we calculate arithmetic mean, it will consider all the values in data set, as it will add all the values and it will divide those values with the total number of items. So it is regarded as being more respective of the distribution. So next point is it is very simple to understand, as arithmetic mean is very least affected by the fluctuations in the sample. So the arithmetic mean is very least impacted by the sampling fluctuation, as it is very much understandable because it compared the large number of items in a series uh, to calculate the mean. Next, convenient method of comparison. So arithmetic mean basically provides a simple way to compare two or more distribution. For this reason, it is very convenient method for comparison purpose. If we want to compare between two or more distribution, then the method mean is very convenient to use. Next is algebraic treatment. So as arithmetic mean can be algebraically treated, it is commonly employed in the computation of several other statistic measures also, like mean deviation, standard deviation, etc. These topics we will discuss in our further lectures also. So as it can be treated mathematically, as in calculating mean, we will consider all numerical value, all the values of the data set which we have calculated from a sample of the respondents. So that's why it is a algebraic treatment. Next is no arrangement required for mean. So the calculation of arithmetic mean does not require any grouping or any arrangement of the items as we have to do in median and in mode. So for calculating mean and median, we have to especially for calculating median, we have to place all the data in ascending order or in the descending order to calculate the value. So these types of arrangement we need not to do while calculating the mean. So these are the some merits of mean. After that, let's come to the disadvantage, or you can say demerits of mean. So there are some demerits of mean are here, as arithmetic mean matches the majority of the priority for a perfect average calculation, but it also has some on the other hand it also has some demerits, and it need to be used carefully. So the demerits, first one is affected by extreme value. So as mean is affected by the extreme value, as extreme value have an undue influence on the arithmetic average, because it is calculated from all the values in the series. So whether there are very small or very large values, they are affected. Next one is assumption in the case of open-ended classes. So basically, it is very impossible in the case of open-ended classes to calculate the arithmetic mean. So without making any assumption about the magnitude of the class, we cannot calculate the mean of open-ended classes. Next is absurd result. So arithmetic mean sometimes provide result that appear absurd. For example, if the average number which is provided, average number of students in class, in a particular class and in a particular section comes out to be 15.6 or 14.5 or 20.5, then obviously the result or the average is absurd, as children cannot be divided into fractions. Okay, so sometimes the results of mean can be absurd or it can come into points. So next point is not possible in the case of qualitative characteristics, as we have also discussed earlier that for applying mean, for calculating, for statistical analysis or for conducting central tendency, the data should be in quantitative. So we have to convert the qualitative data into quantitative data, into numbers. So it is not possible for me to apply on qualitative characteristics, as arithmetic mean can be computed for only qualitative data. So such as data on IQ or on a beauty or on honesty of a person. So these they only appropriately average in case of the median. So you cannot calculate anyone's beauty with the help of mean until and unless the beauty is defined in numbers. Next is more stress on items of higher value. So the arithmetic mean, which is placed, give more emphasis on higher items in a series than it does on lower items. So this basically means that it has an underward bias. So if 3 out of 4 items have small values and one is quite big, so the average will be significantly increased by the big value. However, the opposite is different. If a series of 4 items consists of 3 items with large value and one of the item with a smaller value, the arithmetic average will not be significantly decreased. So there will always a more stress on items which have higher values. Okay, so next complete data required. So without all the items in a series, it is impossible to calculate the arithmetic mean, as arithmetic mean is the total of all the items which is divided by the numbers. So for example, if the value of 99 out of 100 items are known, so then the arithmetic average cannot be determined. So in this case, the median and mode average do not require complete data. But for calculating average, you need complete data. Okay, if you do not have a complete data, then you can apply median and mode. Next point is calculation by observation is not possible. So in case of arithmetic mean, it cannot be estimated by simply observing a series, just like in the median and in the mode. So for this, the data is normally distributed. Next is no graph use. So in mean, there is no graphical representation. You cannot use or you cannot draw any graph to calculate arithmetic mean. Okay, next is there is no existing value as a mean. So an arithmetic average might sometime be fictitious. So the last point is non-existent existent value as mean. So an arithmetic mean or arithmetic average might sometime be a fictitious figure that does not exist in a series. Like 10, 12, 19, and 27 have an arithmetic mean of average 17. So but there is no item in this series that have a value of 17. So sometimes mean provide a non-existing value as a mean. Now next topic, let's come to the next topic, median. First understand with the meaning and properties of the median, then we will come to its merits and demerits. So what is actually median means is, so basically median is a point in any distribution below and above which will lie half of the score. So median is the middle score of any order distribution. So this will be the particularly mid value of any score. So if we take the example to discuss the earlier of the marks obtained by 100 student in science test, which we have discussed earlier also. So these marks can be arranged in an either in ascending order or in an descending order, or you can take any marks of your class test. You can arrange that marks in ascending order or in descending order. So the middle score in that particular distribution is then identified as a median. So thus this would seem very easy for an odd number of score in case of even number. So of score of a certain procedure is followed that will be discussed when we learn how to compute median later in this topic. So basically median is the middle value of the data set in which the data set is arranged in the ascending order on the descending order. As you can see in this example on your screen, so there is a data set given here which we have arranged in an order. Okay, so when the data set contains an even number of values, then the median value of the data set can be found by taking the mean of the middle two values. Okay, so the median, what is median is? So median is basically the middle value in distribution when the value are arranged in ascending or descending order. So in this example, the median is 57 as it is the middle value or the center point of the series. Okay, so the median basically divides the distribution in half. Okay, in 50% of the observation. So in a distribution with an odd number of observation, basically the median value is the middle value. Okay, so if we look at the retirement age distribution as we have seen in this, so we have arranged this all the values in a series, and here the median value is 57, or we can say the median score is the 57. Okay, so this is the meaning of median. Now I hope you have clear meaning of the median. Now what are the properties of median basically are. So when we compare to mean, median is less sensitive to extreme score or the extreme outliers. So when a distribution is skewed or is systematic, then we calculate median. And if the data is asystematic, then we will calculate median. I have earlier also told that if data is systematically distributed, then we will calculate mean. If data is asystematic, then we will calculate median. So when a distribution is open-ended, that is actual score at one end of the distribution is not known, then median can be computed. Okay, so these are the properties of median. Now let's come towards the merits and demerits of median. So as median is a statistical measure like mean and is used to describe the middle value in a set of data. So when the value are arranged in ascending or in descending order, it is often used to measure a central tendency. Okay, so like we have calculated in mean and mode. So there are like median also have some merits and some demerits. Let's first discuss the merits of median. First one is resistance to outlier. Okay, so this is one of the most significant advantage of median is that its resistance to outliers. Outliers are extreme values that can distort the mean significance, but they have little effect on the median. This makes the median a robust measure which deal with the skewed and unsystematic data. Okay, next one useful for ordinal data. So the median is particularly used when dealing with ordinal data, or you can say that for unsystematic data, where the data point have a specific order or a specific rank. So it provides a meaningful measure of central tendency with assuming equal interval between data points, which is required to calculate the mean. Next is easy to understand. So the concept of median is very easy, understandable and explainable. As what we have to do in median, we have to arrange all the data set in ascending order or in descending order, and we can find out the middle value very easily. So this median is widely accessible to the audience, which includes those who are not with the statistic background. Next is applicable on non-numerical data. So unlike mean, which require numerical data, the median can used with both numerical and non-numerical data. As mean is only used on numerical data, only quantitative data, but not on the qualitative data. But median can be used on both qualitative and quantitative data. For example, if you want to calculate the median for rank, preference or ordinal category, you can use median. Okay, for this you cannot use the mean for calculating this. Next, let's come to the demerits of median. So like merits, there are some demerits also for medians. So first one is it may not require the typical value. So in some case, the median may not represent the typical or the average value of data set. This is especially this is especially true when the data is systematically distributed. For example, it is highly skewed data set or median not aligned with the majority of the data points. Next point is limited use with interval or ratio data. So median is not as informative as the mean. So while dealing with the ratio data or while dealing with the interval data, the continuous data or the equal data between the value is required. So it can capture more information about the data distribution in such cases. Next point is computa- uh, com- computationally intensive for large data. Next point is computating, computationally intensive for large data. So for calculating the median can be computationally intensive for very large data set. So especially when we done manually, sorting the data before finding the median can be time consuming for extensive data set. Okay, so next point is loss. So next is loss of precision. So when dealing with discrete data, the median may result in a value that is not present in the data set, which can lead to a loss of precision. Okay, so these are the merits and demerits of